Finally, something is a factor if and only if when you do it, the remainder is 0. That kind of makes sense. When we have if I consider something a factor, it has to go in there evenly. So let's take a look at a couple problems here. I want to use the factor theorem to determine if the polynomials are factors of f of x. And then I want to factor it as much as I can. So I'm going to start here. I'm given my polynomial, which is, I'm going to make this a little bit bigger. Given my polynomial, which is x cubed minus 18x squared plus 60x plus 25. And I'm going to see if x minus 5 is a factor. So I put 5 into my box. Now I go 1x cubed, negative 18x squared, positive 60x, positive 25. If it is a factor, I'm going to get 0 for my remainder. If it's not a factor, I'll get a different number. So let's bring that down. So 1 times 5 is 5. Negative 18 plus 5 is negative 13. Negative 13 times 5 is negative 65. And so I get negative 5. I get negative 25. I get 0. So yes, this is a factor. Now let's see if x plus 5 is a factor. So I could put in negative 5 here. I don't have to do the whole thing. I can just go back to my new polynomial, because if it's a factor, it'll go in this number. So I bring down the 1. 1 times negative 5 is negative 5. I get negative 18. Negative 18 times 5 is 90. I get 85. So it's not a factor because we get a remainder. So now let's write our polynomial in factored form, because I know the first factor is x minus 5. My second factor is going to be the depressed polynomial, because remember we started at x cubed, so this is x squared. So the x squared minus 13x minus 5. And that does not factor, so we're done. Let's have you try this problem and then come back and check.